Kinder from Autodesk was scheduled to be here, but he was pulled away due to an unavoidable issue. His colleague to my right here, Whatmough, was kind enough to be with us here today, although he was going to be with us anyway. Al is the Director of Product Management Manufacturing at Autodesk. Al has been part of the Fusion CAM journey from the outset, and he now leads product management team in the business group responsible for digital manufacturing sections at Autodesk. He has a very rich background, which includes teaching, CAD/CAM expertise, and he brings a very unique perspective to his role. And why is that? I believe that it impresses me that he's quite a social media influencer, in my opinion. But even more than that, the thing that impresses me the most, having to get to know him for the last day or so, is that he's a machinist by trade. So he's earned a tremendous amount of respect around here. Al's quick to point out that his title includes the words product, and he believes that maintaining meaningful connections with his users are key to Autodesk's success. Like many of us, Al finds himself on the road quite a lot, and it's very obvious that he uses his interactions with customers to learn. So it's very safe for me to say this individual, he just gets it, and we're so honored to have him here today. So could you please help me welcome Al Whatmough from Autodesk. Al?
Were all of us at dinner last night? Yes. Yes. I don't know how many tables talked to me at 2. It's pretty incredible to see him walk around and say hi to all of us. There were many of us. When he was walking around, he talked about the desire of this event is for people to end up inspired and to learn something. So hopefully I can do a little bit of that. There's a lot of different kinds of people here. I'll start with my first trick because you said I was a machinist, and sadly, yes, I was a machinist that made real parts. Then for a little while I was an application engineer, so I jokingly say I made fake parts for a living, and the other application engineers know that. Sadly now, I got into machining because I wanted to see what I did at the end of the day. I didn't want to spend my life behind a computer screen, and I thought it'd be a role where I'd be home every night. Didn't work out for me. I travel for a software company, and I make PowerPoints for a living. But this is going to be my first little trick. I learned it fairly early on. The hardest way to start a presentation is getting it started. We heard in the robotics presentation that the hardest way to get into robotics is just taking that first step. The hardest thing making your first part is making the first part. It's the same thing for a presentation, because Autodesk's slogan is make anything. And really when you think about making anything, it's all the same, whether it's a house or a bridge or a movie. It's all kind of got some of the same fears. For me, the way I get over a presentation, that first step, I just start with a video, and then I start to say, well, I didn't do that this time, but I'm going to start with a video this time. And it's a trick if any of you are giving a presentation. It's a way to start with a little bit of a win. Maybe it'll be a win, maybe it won't. But that's kind of my first trick. So this is just a little introduction to Autodesk. That part was made on a Mazak in California. That shows a little bit of a breadth of the company. The other reason I started the video is early in my presentations, I also have to show that. It's not quite as fun, but I'll put it in layman's terms for all of us, what makes sense to me. It's the Autodesk Safe Harbor. Basically, what that means is it tries to keep our salespeople honest. And as a company, we want to be transparent about what we're doing, but we also can't sell futures. So it's this interesting balance between being transparent and not having somebody buy something that's not yet built. And so all this is saying is if I tell you something about what we're doing or share an opinion, it's not a commitment on Autodesk behalf. It also means you can ask me whatever question you want, and I can answer it because you just saw this slide. So I hope that we keep this conversational. It's a good way that we can stay transparent and also make sure that we don't end up in jail for selling futures. Okay, so Autodesk, I told you a little bit about Autodesk, and I really want to not make this an Autodesk commercial, but it's hard because all my slides are going to have Autodesk stuff in it. But I think it will refer, and I hope to have it refer to the software industry in general and show a little bit about what our perspective is, because it is a little bit unique in the sense that we have three major verticals at Autodesk. The one that most of the people with more gray hair maybe would know us for is architecture. It's how I used AutoCAD in high school probably. That's certainly where we started 40 years ago and have a significant amount of market share there. On the far left, you may or may not know this, but I think it's in the last 20 years, there hasn't even been a Grammy-nominated movie that didn't use Autodesk software for special effects. So our software is heavily used there. The place that traditionally we've been a little lighter is in manufactured products. That's the group that I'm inside of, and I'm responsible for all of our digital manufacturing, so anything that's 3D printer, CNC machine, laser cutter, anything of that. So hopefully that helps frames it and at least gives the perspective, so you can ask questions on our perspective. And yeah, I apologize, I really don't want to make this an Autodesk commercial, but I think it helps understand our perspective. But with that, all of us together, we're seeing a lot of change, and some of that change can be anxiety-inducing. I love change, but also I'm nervous of change at the same time. Some of the changes we see, a lot of products that are delayed, so it's our job to help build products to speed that up. By 2030, the stats says there's going to be 5 million unfilled manufacturing jobs. If I remember the stats correctly, it's about 2 million in North America, surprisingly almost 3 million in China. So a significant number of unfilled manufacturing jobs. And global productivity is starting to plateau. The amount of output that we're creating is starting to plateau a little bit. So those are some of the things that we're seeing, we can probably all see. Another unique perspective that Autodesk has that may be interesting to each of you, because we see where construction is happening. The construction team tells us in the last 12 months they've seen an 80% increase in construction for manufacturing facilities within North America. So some big numbers that we're seeing in that regards to change. When we think of change, we think, well, change is disruptive. Change is disruptive for all of us. And a lot of what I'm telling you here is kind of my story and our story and how change is disruptive, and it can be. But that can be a good thing and a bad thing. Whenever I think about change being disruptive, I think back to college drafting, where I actually got my worst grade in college, which is weird because now I work for Autodesk. So many strange things in my career went ways I didn't expect. But that drafting teacher told me parametric modeling is the worst thing that ever happened to the draftsperson. And to some extent, he was right. If you didn't want to change and you wanted to spend your life saying, how does a front, top, and side view line up with each other? But with parametric modeling, the world started to change, and the draftsmen started to think about what their design intent was and how they captured the intent of the design, and we automated away the creation of 3 views. So each time there's a step in automation, it creates an opportunity for us to do more. That's a challenge. For some people that's exciting and you can attract new talent. For others, it's a fear that we have to get over. The video I showed here was a bunch of guys that loved racing, and the fact that the product was more accessible, that was a change in their industry, and they were able to design their own products for racing. And in the background there's a Hooligan Pikes Peak car that they did using Fusion. So it creates this new opportunity for new people to get involved, and I think it's an exciting change. This one's kind of a funny one for me. We all look at that and say it's faceted, But these people that didn't come from manufacturing saw the faceted model and said, that looks super cool. So they made it that way, where some of us probably look at it and think that's weird. But it's another sort of aside when you're thinking about reducing cycle time. Sometimes we're so focused on getting the finest step over or that sort of thing. And then we see these artists that are making products and they have an aggressive step over and their customers are like, wow, that's got a machine look to it. So sometimes you can think differently and say, how does the manufacturing process actually influence the design? So instead of trying to think about how you manufacture things, you can take your understanding of manufacturing and let that influence the design. All right, the slides are getting ahead of me. So there's one thing I do now is I make PowerPoints, and I'm not doing that great of it. So anyway, so this is sort of like where we're seeing the industry, and this is our view of it, but it's no different than the view that others would have. In the early days of CAD, CAM, CAE, PLM, and put that in layman's again for things that I can understand, CAD is really about creating the geometry, and then CAM is about creating toolpath or motion for that geometry. CAE is when we start to analyze parts to see if it's going to bend or break, and PLM, kind of think of it as like a Band-Aid. It's a side thought that says, how do I tie all these tools together? Because as an industry, we gave you a bag of parts, and that was our solution to kind of tie that bag of parts back together again. But we kind of looked at this and said, well, why are all these tools different tools? It's very similar to the Mazak approach of one and done. Software wasn't there. And we felt software needed to be there. How do we bring the tools together to have a better solution? And I can say this joke because I'm responsible for standalone CAM systems too. So I can say that at a feature CAM and Power Mill, and those are part of my responsibility. I'll kind of jokingly say as a machinist, what's the difference between an integrated CAM system and a standalone CAM system? And my personal feelings, one's got crappy CAD. Because you end up as a machinist with the lowest common denominator of what's required to do the job, because that's what the industry had to serve you. Whereas, as we build CAM for an integrated solution, and there's many, it's not just us, and I'm not saying standalone CAM systems are bad, typically they're stronger in certain areas, but we get the advantage of some of the CAD tools that were previously reserved for just the engineer. And it becomes more accessible to us. So as manufacturing people, go back to that point I made, really good design takes manufacturing into account. It's empowering us as manufacturing people to move further up in the process because we've got this unique insight. Everybody that does manufacturing has to know how to use CAD. It's part of what we do. Not everybody that does design knows how to manufacture, so I think it's very empowering for us. So we get to this point of convergence, and that's what I'll show you is what we're trying to do to tie all these pieces together. I'm going to show you some of the things we learned as you tie them together. Some things are surprises, and I think you'll see the same thing if you've got products that you end up tying together. All right, so a couple of questions, and I'm going to end with the slides with the questions on again, but just be thinking about, so I'm going to talk through how these changes have disrupted us and how we've brought our staff along, and I guess I'm one of those people that came along for the ride. But what does that mean for you? And I think that'll make a good conversation at the end of the presentation. And the same thing, what does it mean for your company? A probing question, does it solve the skills gap or does it make a bigger one? I've got an opinion on that, but let's think through that. How do you bring your staff along? And in some cases, you're wanting to bring people along. In other cases, you're creating new opportunity. You don't necessarily want to force people. I think in every change, you want a level of stability. So it's not a bad thing to not have everybody want to change things, but you want to create balance in that equation. So again, I think something we can kind of think about and talk about at the end. So this is kind of the perfect world that we see. It's kind of the one and done of the software world. Can everything be talking together seamlessly? The reality is, it's not. This is what the world looks like today. And some of these products are ours, some of these products are other people's, but as an industry, we basically said, here's all the parts, figure it out on your own. And we spent all the time making the toolpath that would do the fanciest thing and having the simulation that shows when something's bent or broken. But we didn't really put the effort in we needed to fuse the pieces together to play on the name that we've got. So this is the world we see it, and we're not alone in this. Many of these players, and you're seeing acquisitions happen over all our industry. So I'm not saying like it's it's just us. This is just my slide view of the software world, of these disconnected processes that we feel I need to connect together. So like I said, that's why we built Fusion. How do we bring all of those experiences together into one thing? Now, the interesting thing is building software, again, is like building anything. Each of these products, if you asked a machinist, what's the right way to make a part? Every one of them, including me, will give you a slightly different answer, and will all be right. And the same exists in software. Each one of these products on their own had the right way of opening a file and the right way of navigating a view, but when you say you want to pull it all together, often the biggest challenge is, I shouldn't call it a people challenge, but it's a problem with getting people aligned. The tools are often the easier part of the problem. And I think you'll find the same thing with any of the challenges you have in trying to integrate things together. So there's 3 factors to really drive this change. When I started at Fusion, I took over product management for Fusion 2 weeks before we started the launch of Fusion 360. And at that time I was told, this was basically, there's been a little bit of inflation, but basically you're going to be selling CAM software that used to be $12,000 for $600 a year, go do it. And it kind of took me back a little bit, like how do we possibly do that? And it makes you think, how do we reimagine how we bring this to market, because we can't do it the same way that we did it before, but it's part of our core belief is we want this product to be accessible to everybody. We have to remove some of the barriers to make it accessible to everybody. So that's one of the factors. When you're trying to make a product more accessible, you want to think about it in all ways. And in the end, it works out just fine. We haven't actually diluted the market at all. We can do the pencil math at some point if you wanted to, or if you wanted to probe me on that. But the go-to-market and how you price a product has to be aligned with the vision. Our vision is to make the product accessible, so this was part of what we did. The other part of the product, and I said this or you said it in my introduction, more of the product is the community than the product. That sounds like a really weird thing to say, but for the folks here buying a Mazak, you're not here to see what one of the great application engineers could do on a machine. You're here to be successful with it yourself. So a large part of the overall solution is how do we help make people successful, and for us, it was about making people successful at scale. It was about developing a community. So that's a big part of the product, and I think that goes for any of you. We've got many, I call them good friends, and they are good friends. Dave's one of them. John Grimsmo is the one I'm thinking of now, that makes knives, and he's created this community around his knives. And that community is as much his product as the $1,000 knife that people buy from him. So I think it's a big thing to think about. It's something that I clearly see with the Mazak community too, of talking about creating a community, again, going back to seeing talk, walk around, and have a conversation. That community is something that I really think you want to be involved in when you're looking for a partner too. So when you're looking for a partner, is the community aligned with your support? When you're looking for a partner, is how we're compensated aligned with you? So maybe we should think about this just for a minute. When you look at that pricing, that's actually a model that aligns our motives very well. In the old world, when I could sell you CAM software for $10,000, I was motivated to sell it to you and walk away, because my next big chunk of money was from the next person. In this current subscription world, I'm motivated to keep you happy every year, because if I don't, I've lost. And actually, what drives my success as a product manager is not the dollars at all. What they track our group on is we call CAM monthly active users, but how are people adopting the product? So I think that's one thing to look for in change. Are you finding a partner that has mutually aligned goals, so that how you compensate them, does that drive them to give you the value you want? Do they have a community that's going to support you, or are they going to deliver you a product? That's my third slide, the product. Are they going to deliver you a product and walk away? And I can tell you it works. When I joined Fusion, we had 0 users. 2 years in, I remember when we hit the first 1 million posted programs. A year later, we did that in a month. This year, we'll add 25,000 monthly active users that are paying subscribers. And I don't talk about the dollars, because that It doesn't matter to me. What matters is how many people are successfully creating NC programs. So again, I think anytime you're looking for a partner, that you're looking for is the community aligned for support, is the financial change, is it aligned to get the benefit that you're after? And then finally, there's the product. So I'm going to start talking about product a little bit. And here should be a quick video just showing how we've started to connect CAD and CAM together. We have a belief that it shouldn't be a closed garden. So what you're seeing here is CAD documents from many different vendors. It's a belief of ours that people are going to use many different tools. We understand that. We hope that if you use the full platform, you'll have a better experience. And the same thing is, I don't think I'm talking of turn to say it's the same thing for Mazak. They know you're going to have other machines, but you'll certainly get a better experience if you're connecting all of their tools together. Okay, so let's get into some of the challenges now of connecting these products together. Because in any change, you're sort of looking and saying, well, I think of it from a product manager, where's my leverage, or what cookie jars can I reach into? And I've got many now. Autodesk has acquired many products for me to reach into. Each of them have their own strengths. I joined at the time of HSM Works, and the strength of that was saying, how do we parametrically connect CAD and CAM together? What do I mean by parametrically connect CAD and CAM together? It's about saying, how do I define my intent? Not what I'm going to do. That's kind of the AutoCAD way of doing things, where you explicitly define things. But how do I capture the intent of what I'm trying to do? And that's what that was good at. And it starts to change the way people work even. I'd be curious how many people put their work offset on the top of a part. And you have this debate all the time. And you think, well, why do you put a work offset on the top of a part? Typically that's because when you program by hand, you wanted to avoid an issue of accidentally going into the part, so you've built these muscle memories and habits around avoiding the thing where something might go wrong. With something parametric, where the toolpath will always retract above the part, that's no longer the biggest problem. The biggest problem is, did I put 0 in the right place? So it's actually now better off to put 0 at a common point in a work holding solution that might even be below the part or at a fixture, because the operator setting the wrong 0 is the more likely mistake than the programmer accidentally typing in the wrong value. So we start to change our habits when things change. But each of these products has strengths. Each one of these things has a simulation product. So I think of this as putting a puzzle together, but I've got many of the same pieces. Every one of those CAM products has machine simulation, but still as an industry, we didn't finish our job. There was actually a company that could make a joke on it, and they called themselves CAMplete, because the CAM company didn't complete our job. We ended up acquiring them, and we're using the basis of that technology to run simulations. Say those are puzzle pieces we don't want from other products. PowerMill is good at milling, and other products are good at other things. So here should be a quick video of showing how we've started to integrate many different processes together. And what you'll see in this video is some 3-axis toolpaths, some 5-axis toolpaths. Some of those came from one CAM product, some of them came from another CAM product. Metrology that came from a different CAM product. It's all seamlessly together in the same browser, and you can output it to any kind of machine type. So the goal is to say, how do we break these puzzle pieces down to their core bit so that it's more scalable? And I believe the same thing happens no matter what you're making. We're just doing that in software, but to me, well-running shops have done that with their work holding and their tooling. It's this idea of saying, how do I break things down to the root of what they are so I can put things back together? And now we start to see the benefit of, well, what do we learn when we take technologies that existed for another industry, in this case fabrication? It forces us to think about, how do we think about how we utilize stock? And the teams can focus very deeply on utilizing stock, because as things automate, you end up with people with deeper levels of expertise. In this case, now we can put together the arrangement of material alongside other things, because what it's done by automating part of the problem and saying you've got a shared framework, the folks that were experts at nesting in particular didn't have to worry about all the other problems. They became experts. And that's starting to poke at what I was saying with the skills gap, is the more we automate, the more deep expertise you have when you push things forward. And I think it's an exciting opportunity, but it's also a challenge. This last one is just showing a little bit of additives. So this has started to push our muscle memory to say, well, how do we start to think about geometry manipulation? Because I had a conversation, I think it was Chuck, maybe somebody else. To me, all additive is a 3D or a digital casting almost. Think of it as a near net shape that's going to get the thing in the right place. So you're doing a lot of the same things as if you were designing for a forging or a casting. It's just you can do it in a digital way and not have to build a mold. It's good at building a shape, but when you get high accuracy, it's very slow. If you get a fast 3D print, it's not as accurate, but you can machine it. So now you can see again how we've stitched together different technologies. It's our idea, one and done. How do we put the different technologies for CAM together? Simulation's an interesting one too though. So I'm going to show this video only to have you think about in your shops, when you're bringing different technologies together, sometimes you'll have an aha moment that says, well, we've got this tool that tells you, and the same actually applies to machine simulation, but we've got this tool that tells you when it's broken. Why do we even do that? Instead of using the tool to tell you when it's broken, why not take the same inputs of where the loads are, but just generate the geometry that will work? So sometimes you end up deep down a rabbit trail of fine-tuning a problem when maybe all the math you did will solve the problem in a better way. So this is generative design, and it's going to create some shapes. Today we can make it so it can constrain to cutting or machining. So it's one of the benefits of bringing these tools together is we also get to educate our CAD teams to tell them how to build products that are more manufacturable. This is my other little tip and trick, because usually people see generative and they think, well, that's really weird looking shapes, I never do it. But again, the creative machinists start to think, well, how would I use that tool differently? Every one of us creates weird geometry to hold apart for one and done type workflows. It's actually a great geometry creation tool to create some geometry that you would just cut off anyway. So thinking about when we gave you access to a tool you didn't have before, that's what we all do as makers at heart, is how can I use this tool in a new and creative way? So again, it's just a thinking to constantly be looking and finding creative ways. And I think the people that find this are usually not traditionally from manufacturing, so that would be my encouragement for you. If there's younger people in the shop, they're more likely to look at things from a different perspective and find new ways of using tools that were built for a different reason. All right, well, I've talked a lot about how we're trying to help automate your workflows. This one's a fun one we've done with Mazak to connect directly to the machine control and at first help us dial in the post-processor, but long-term, our first process was how do we connect CAD and CAM. Now we're talking about how do we connect from CAM to machine tool. Because at the end of the day, all a CAM system is a way for a user to find geometry and apply manufacturing parameters to it. So the geometry problem is connecting to a CAD system. The manufacturing parameters really come from the machine. The other thing it's done for us, and I think this is like the interesting thing and the scary thing about automating. Post-processors in our traditional CAM business was 15% of the revenue. So that group, before we came together, said, well, we can never give post away, it's too much revenue. And we kind of said, well, we can't afford not to because it gets in the way of 100% of sales. So as we automated it and gave posts away, we didn't lose the post team. We freed the post team up to do more innovative stuff like this, which is a lot more interesting for them than writing onesie, twosie post processors. But it's a bigger challenge. So as you automate things, my personal opinion is you don't solve the skills gap, you enable people to do more, and we're going to keep trying to push things forward. In our case, it freed up a team of post engineers to push the ball farther, and in this case, we're able to partner with Mazak. There is a piece here too that I just thought I'd show, is thinking, because we live in a world where not everything's the new shiny stuff. We did the technology to measure on a machine tool, but in many cases there's simple things like Bluetooth calipers and that kind of thing. So within the same framework, in the same way you define how you want to capture a measurement, what device you use is independent of defining what measurement you want to capture. So in this case, I'm just showing how you might use a Bluetooth caliper. And again, the thought is really to think about what is the general thing we're solving, and then where are all the other ways you might grab an input. All right, a couple little things on what's next, just in case you're interested. I usually show this only with our community, but Mazak invited us here, so I thought I'd tease a little bit about the kind of things we're working on, specifically a big focus on turn mill for us this year. Automation is always a topic, so I'll share kind of our belief on automation. It runs alongside a human, so this is a prototype that we've got now, where the user outside of the authoring client, so in this case they're a browser, they're applying a cutting manufacturing, I call it a recipe, but a method of manufacturing a component. You can apply that. The toolpath will generate outside of the user experience, but then the user can then later open that toolpath up and take a look at it in the full client as if a user created it. So far everything that's happened here is largely without user intervention, with the exception of saying this is the template that I want to use to run it. And then later in the video, we'll open that up in the full experience to have a user fully go through that. And I think it's another important thing is as we get closer and closer to automation, you still need users, but the users are no longer doing the menial tasks. Now the users are kind of running alongside the thing that's automating them. I think this applies to almost every industry. Chuck and I were chatting, I think it's your son that's a pilot, right? And as we got autopilot, there's not less pilots. The pilot doesn't have to do stick and rudder skills anymore, but now the pilot's thinking about navigating and avoiding weather patterns and thinking about a higher order problem. So each of these times we talk about automation, whether it's us automating the software world, then we're thinking how to better connect to machines. If it's you as programmers automating a specific process, you can concentrate more on a wider part of the problem. The last thing that I wanted to show, and this is, again, it's because we love our partnership with Mazak, but in this case, we're just about to release this. This is a full G-code simulation inside of Fusion, working alongside the Mazak team. Oftentimes when I show this, I'm asked, well, you're going to charge more money for it, right? And the reality is no, and I'm not saying this to be a sales pitch, but we said we're never going to charge anything more for anything that's a safety feature. So this is part of every access point of Fusion to have this, but it's also our belief more people should be involved. We believe a tool like this is something an operator could use, and that can help encourage the operator to move from being an operator into being a programmer. So we want to make sure that things are most accessible. I think that's another thing to think about. Sometimes the thing you charge the most money for in the past, I can't believe it was a $16,000 or $17,000 product. That's the thing that actually makes things more accessible, not necessarily where you get your value in the future. You need to rethink what relationship am I trying to build with the customer, and how do I change how we exchange value to make sure our interests are aligned, and our interests are aligned to have more users being successful. So I think it's a big thing, because if you think of any change in any industry and you think through just one of those three lenses, community or how you take the product to market or the product itself, then it's likely to fail. But if you do all those things in concert, then you're likely to have an amazing success. The last thing that I'll think about, and I think this is the thing that's exciting for me, we're starting to see that with a cell, but as we automate more manufacturing, where do we think things are going? Well, the more we automate what's wrapped inside of a sheet metal box today, we call that a machine, it's starting to become a cell, and we're seeing cells out there with a machine and a robot, and maybe an equator sitting next to it. And so that cell is now the thing you're thinking about programming. And beyond the cell, then you're starting to think about how do I run the entire factory, and that's where we start to see more of the Autodesk pieces converge with how the factory is designed and how we start to run things inside the factory. And the last one, and maybe this is a little bit of a plug, but education is obviously important to us. Anything with an Autodesk logo on it's free for educators. We can do that. In our case, cost of goods sold for software is zero. So there's no point getting in the way of having students be able to use the products. So any Autodesk product, I don't think there's any exceptions to that, is free for students. All they do is show their student card. Okay, well, I hope that kind of wasn't a sales pitch. Maybe it sounded like it. But the idea was to sort of express what we've gone through with driving a change that I think many of you are seeing in terms of Fusion being nowhere in the industry to a significant player now. Some of the things we've thought through, have we done it? I'd love to have some conversations about how it might apply to you or really any questions.